Okay, so chapter 14. We are talking about conic sections. Conic sections. We're talking about cones. Now, take notes. Get out your pen, piece of paper, and as we go through this, each one of these sections, then I highly suggest that you write down what we're talking about and draw it out and identify what it is that we're talking about. Okay? If you do that, your homework should be very, very easy. And it really shouldn't take you that long to do. We can make this chapter much more complicated. I don't think it's necessary, because if you go actually in depth with this, then that's where you're getting into some of your specialized math courses. I think it would be better if you spent more time focusing on the simpler sides of things, and then you'll remember what it was that you learned about it and apply it later on, and then go advanced with the advanced math classes. Does that make sense? Good. Yay. And they all rejoice. Yay. All right, now, in our current textbook, we would start with chapter 14.1. Okay? Your homework assignment on this is going to reflect some definitions. What I am suggesting that you do is we hold off on this first section and do it last. Okay? Once we go through the rest of the chapter, if you read the questions, your homework assignment, you'll be like, oh, now I know what they're talking about, because you'll be looking all through that first section and not know what it is that they're asking of you. You can try to answer it, and you might get lucky. But as we go through the rest of the chapter, it's going to be really easy to identify those, because you'll go back through the chapter. Oh, it's this one. It makes sense, and here's the answer. You'll see what I'm talking about here in a few minutes. Okay? So let's skip over to section 14.2. 14.2, we're going to be talking right now about circles. Now, all of this is related to cones. Cones. So as we venture on, we're going to see some sort of diagram like this. Okay, so you have a snow cone cup, tip to tip to another upside down snow cone cup, essentially, is what we're dealing with. Okay. Now, on section 14.2, when we're talking about circles, a circle is defined as the intersection of one nap of a right circular conical surface and a plane that is perpendicular to the axis of the conical surface. Does that make sense? Everybody got that? No. Everybody shake your head no. If you do know, good for you, because you're way ahead of things. Okay? What we are going to be discussing through this chapter are essentially the cone and how a plane intersects with it. Okay? And then we are going to go into a little bit of graphing, how some of these will be displayed, or what takes place as the plane interacts with the cone, and then how that particular object, whatever object is created when that occurs, how that may be graphed. So what we're talking about circles here is whenever you take a sheet of paper and it is parallel essentially to the base of this cone, or to the top or lid of this cone. So we will have some sort of plane that cuts through like this, and as it cuts through, it is going to make a circle. Okay, if you were to take this plane and it is parallel with the base, this piece of paper is parallel with the opening of that shaved ice cone, and then you separate those pieces, you will see that both this part right here and this part, where it's split, is going to make a perfect circle. A perfect circle. Does everybody see that? I'm not the best drawer when it comes to these. But the biggest idea behind this, or understanding, is that this plane is parallel to that base. Okay? If we go back and read the definition again, there are actually two that we'll talk about, because there's two things that are occurring. It's the intersection of one nap of a, don't worry about the word nap right now, of a right circular conical surface. A right circular conical surface. That's what this thing is. And a plane that is perpendicular to the axis. So if the axis were to go straight up from the bottom all the way up through the middle, it is perpendicular and therefore parallel to either the base or to the opening. Does that make sense? Now, another way to consider this is the other definition, where it is a locus of points in a plane, a fixed distance from a fixed point in the plane. Okay, so it is a fixed distance from a fixed point in a plane. So what that is saying is there will be one point which is going to be the center of that circle, and a circle is defined as whenever you have a point and every part of that circle is equidistant from the center of that circle. Okay, so that's what it's essentially saying. There is this fixed point in the middle, and the plane, where the plane and that conical surface interact, it is equidistant from that center, from that one point, which creates a circle. Okay, so two different ways of thinking about it. Does all this make sense so far? Pretty easy, right? You have a cone, you have a piece of paper is parallel to the base of it. It makes a circle. Ta-da! And we're done with that. Now, what's interesting about that is there is an equation that we can write if we are given what the actual coordinate point of that circle. Okay, so now we're talking graphing. If we had that circle and we were going to graph it, we could determine the size. Actually, we can determine the equation if we know what the original coordinate point is and the length of the radius. Or if we were given an equation, we could then figure out what that coordinate point is and the length of the radius. Okay? So, everybody write down this equation here. Sure. This is an h. So x minus h squared plus y minus k squared equals r squared. So if we were given a coordinate of 3 and 7 and the radius equals 6, let me do this. This is going to be your h. This is going to be your k. Or h is going to be your x part of your coordinate. K is going to be your y part of your coordinate. And then r equals radius. Length. Depending on which way you prefer, it doesn't matter. So then what is really easy about this is when we plug it in, it will be x minus 3 squared plus y minus y minus 7 squared equals 6 squared. So we were given a coordinate point and a radius length, r equals 6 in this particular situation. all we do is plug in the x part of the coordinate with h, the y part of the coordinate with k, and the radius length for r. And that is our equation. So let's test and see how well you are paying attention. If I were to do x minus 5 squared plus y minus 9 squared equals 8 squared, write down the coordinate point or the center. Okay, that coordinate point is the center and the radius length. Your coordinate point, based on this, from what we've done here, write your coordinate point for the center of the circle and your radius length. Okay, so let's hear some of what y'all got. What's a coordinate point?
5.
Okay, and
7.
what?
9.
Who said 7?
I did that 9 too. Alright, first round it.
And then what's the radius length?
8.
8. Not 8 squared, 8. Okay, let's do one more real quick. Alright, do your coordinate point and your radius length and see if you recognize what it should be. It's a little bit different than before, and we'll discuss why and what to pay attention to. Alright, so what do we have for our coordinate point? 7 and what?
4.
Negative 4.
Ooh, -4. Very, very good. Because of that right there. Now, I didn't explain this before because I was wanting to see if people were paying attention to patterns and stuff. Our standard equation here is this, and it's important that you recognize it. Notice that the standard equation is x minus h squared plus y minus k squared equals r squared. So if we result in having a plus over here, it's because this number is negative. Okay? The negative times a negative gives you a positive, which is why you end up with a positive here. So yes, it would be +7, -4, and the radius length equals what?
3.
3. What if you were told this? What would the radius length be?
4 7 squared. Yeah.
Nobody's actually correct yet. What's the radius length?
Square.
I think squared. 49 squared.
Think about your standard form and what form it is in. What form is this in? And how would you change it to fit that form exactly?
7 squared.
You're so close.
7 squared.
Is it just 7?
It's 7, not 7 squared.
Oh, because the square already comes.
Yes, the squared,
Oh,
or the
okay.
exponent of 2 is part of the standard form. It's just r. That is going to be that length. Okay? So pay attention to that. If you need to make a note that it is not, the radius length is not r squared, it is r. Now if it ends up in a format where it's not, it doesn't have an exponent of 2, that means that you can rename 49 as 7 squared. It's the same thing, and therefore the radius would be 7. Makes sense? Pretty easy, a little tricky, but at the same time this is wrapping our minds around standard form and different ways that you may see it. Change it into its standard form so you can easily recognize what information you need to pull from it. Okay, so now we know how to go back and forth from the standard form back to the our center coordinate point and then the radius. So what this means, we'll graph this. I'm going to, is everybody good with all this? I'm going to erase this, just because it's a lot up here. What this means here is if we were graphing, do it this way. Let me go over some. So if it was 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4. This is our center point. So from here to here, and then here up to here. So from this center point, 7 units away from that will end up making an exact circle all the way around. No matter where you go from here to any other part on the circle, it is going to be 7 units away from that midpoint, that center point. Okay, so the center point is the coordinate here. And again, the length of the radius, not the length of the diameter. If you were given a diameter, then you would have to take half of it to find the radius. Make sense? That's pretty easy, right? It's really not that difficult. All right, so let's carry on. Now, if we have, moving on to the next section, 14.3, we're talking about parabolas. It is not pronounced parabola. You can say that if you want to. Yeah. E. coli. Yes, parabolas. Parabola. So, in essence, what a parabola is in 2 dimensions, it's basically a U. Okay, if you were to graph, typically some of the a lot of functions that we've talked about end up being parabolas like this. Well, we're going to look at a parabola from a different perspective. Now, what's happening is, again, we're looking at our conical figure here, and now we're going to take a piece of paper that is going to come in from the back side, but then as it cuts through this cone at an angle, it's going to leave the cone through the edge of the cone. Okay, so you have this piece of paper right here, and then it cuts through the cone and will end up cutting at an angle through that cone. Part of the piece of paper is going to be about midway, roughly somewhere in the middle of the edge, but the other part is going to come out at the very edge of that cone. Does that make sense? Not above, not just short of, but exactly through the edge of that cone. Think of that one point on the outside part of the circular opening of that cone, and that's where that plane is exiting.
The diagram is a little bit different.
It is a little bit different because what I'm saying is actually incorrect, and I'm sorry. I was looking at the wrong one.
Really?
Yes,
Oh.
I actually am incorrect. So let me back up. It is not the corner of it. I'm sorry, that was my fault. It is here. There we go. That was my fault. I was looking at the wrong one. So it is going to extend through, let me change this, like that. All right, so slightly above the edge of the cone. I apologize. Good catch. Actually, I was just testing you, and you passed this time.
This one's actually
So-
below the edge.
Huh?
This one's actually below the edge.
No, it can be above or below.
Just make sure.
Okay, so let's read the definition behind this, and don't ever correct me in public again.
Sorry.
Just saying. No, okay, so let's read the two definitions. It's the intersection of a right circular conical surface and a plane that is parallel to an element of the conical surface. Okay, it is parallel. What do you think that means whenever it's parallel to an element? What might it be parallel to? Look at, it'd probably be better if you looked at this figure, but think of that piece of paper and this cone. As it slices through, what might it be parallel to?
Is it the edge of the cone?
Conical surface?
Yeah, the surface of it. It's parallel to the actual surface. It's stating it as the element, but think about this angular part of the cone. It's going to, now again, you can wrap this around if you think three-dimensional, but it's actually going to be parallel with this edge. It can come in this way and cut through. Okay? Or likewise, it can go up this way. So if you look at the big X here, it's going to be parallel with one of the sides of the X. That's what they should have said. Instead of going to conical surface and being all smart and stuff, they should have said it's going to be parallel to one of the sides of the X. It's very mathematical. Now, we're not going to even mess with the second definition. Parabola or parabola. Now, what is happening with this is, and I'm going to try to make this as simple as possible. Whenever we look at example number 1, everybody turn to page 582. And as we look at this, I want y'all to also look at question number 1 on your exercise. Okay, question number 1 on your exercise. Now, we are given our equation in the form of y equals a times x minus h squared plus k. Do y'all remember seeing this form from an earlier chapter? Okay, so if you remember up front, this tells you if the parabola does what, if it's positive or negative. Do you remember?
I know
What?
like curves.
Yes, which would be what? What or what?
Yes.
Positive is what? Up. Negative is what?
Positive.
Down. Okay? Then the h, now it has, this negative must be there. This negative affects it. So this negative means that this number is positive. This h, what is it? It translates what direction? Up and down or right and left?
Right and left.
No, good guess, because it's 50-50. But it's actually up and down. And then the k is right and left. So it translates, now this is the point, the lowest point of that parabola, and that is where you will begin. It's actually your vertex, okay? Where your parabola is going to begin, and then it goes equally in both directions. All right? So this tells us, positive or negative tells us if it's up or down. The h says if we translate it up or down, and the k lets us know how we translate it to the right or left. And again, if this is negative, that means that the number for h is positive. If it's positive, then it's a negative number, okay? So with that in mind, we can take question number 1 And we're going to see that, is it going to be go open up in the positive or negative direction?
Positive.
Positive direction. Okay. Now, is it going to be translated up or down or to the right and left? What? How many?
4.
To the right, 4. Okay. And up and down, how many?
4, 5.
Okay. So, and then you add the 1 to the 4 to get 5, right? Which tells you how wide it'll be, right?
No.
I've been messing with y'all the whole time. Y'all should know better. Y'all should know better.
So hard.
See, this is what you have to do. I know it's difficult, but this is how you learn better. Is whenever you think you understand and then we have to break you down and start over, especially whenever we learn this earlier in the chapter. So, as I said, compare example number 1 to your question number 1 to determine what does what. I want everybody to look at it now and tell me what information I was telling you that was incorrect. Look at question number 1 in your homework versus example number 1 within section 4.14.3. What information did I tell you that was incorrect?
The directions of H and K.
How so?
K goes up and down, and H goes right to left.
Very, very good.
So I was right.
Yes, you were right.
And I didn't even get credit for the one time I'm right.
But I was right in that you were guessing, weren't you?
Well, yeah.
Yeah. I could tell, I could read it on your face. But you actually had a certain amount of confidence whenever you said it, but I could still tell.
It was like
Okay.
the guess. I was like, that feels right. So.
Yes. Well, and what's interesting is you're kind of reaching back to what you did learn. But the thing is, being confident in knowing what you did and why. So, let's go back, erase everything that we said, and let's get on track correctly, because this is very important. Okay, so, now, were we correct as far as positive or negative in front?
I don't know.
Come on.
Yeah.
Yes, very good. Thank you for checking your answer, by the way, which is why I told you to do that to begin with. All right, the H, does it move you up and down, or does it translate it right or left?
Right enough.
Right or left. The H, so let's do this. Here, we'll go, the plus or minus is up, down. The H translates what?
Side to side.
Side to side. And the K does what?
Up or down.
Up or down. So if you need to, write this out so that you will remember. All good? That is all I want you to focus on chapter 14.3. Okay? You have your homework assignment. I know it tells you to find certain other pieces of information. I'm not worried about those pieces of information right now. Okay? I would rather you go back and revisit what we've learned here, because this form is what's going to help us the most. And we obviously need to go back and understand it a little bit better. Okay? Cool. So that is 14.3. Now, 14.4. 14.4. Now, what is happening with this is we still have our conical surface. But we are going to end up with an ellipse. And to understand this a little bit better, an ellipse is where you have this point, and it's going to be some distance from here to here from the point, and it's going to be a different distance, but equally so in the other direction from this center point. So if this is, say, 2 points, or hold on, 2 units, this will also be 2 units away. And then if this is 5 units, it will also be 5 units this way. And then whenever we connect the dots, it's going to be like a stretched out circle in one direction. So from the center, going up and down is going to be equidistant from the center. Going side to side is going to be equidistant from the center, but not the same as going up and down. Okay? The distance wide is going to be different than the distance tall. Okay? But there is still a midpoint. Now, in order to accomplish that, this is very similar to what we just did with the parabola, only the paper is not going to be parallel with the x part of this conical surface. It's going to come in at some other angle and as it comes in, it's going to be, and it's not necessarily accurate, but it's close enough, it's going to end up taking an elliptical shape. Make sense? Okay. Now, of course, with this, we are going to be able to graph an ellipse. Yay! Come on, I know you are really enthused about this one. This one is going to be easy as long as you write this down. It's very important that you write it down. Let's look at example number 1. So we are told to graph this So, a squared is going to equal the denominator underneath the x. B squared is going to equal the denominator under the y. At this point, that's when y equals 0. Okay, and so that goes back into we're equaling x equals 0 over here. That's how we're getting that information. So this is one method of getting there. Okay? So it's just, I wanted to do that to kind of recap on something we've done.
That's a lot easier to do that way than is the first way.
Sometimes. In this situation, yes. In other situations, it's really difficult, and you end up with all these fractions, and it's a real beatdown. So, in some circumstances, so what are your basic 3 options? We have where we do substitution, we have addition, and what is the third possible way? Do y'all know?
Okay.
Graphing is one of them. Yes, very good. You can graph them and determine your information. Okay? Now, with your section 1 homework, it's going to relate definitions, and you're going to have to determine, is it an ellipse? Is it a hyperbola? Is it a parabola? Based on the definition. Now that we've gone through the whole chapter, you will know where in the chapter to find those definitions to give your answers. So section 1 is going to be really easy. It's flipping through and finding the correct definition. All right? Wasn't that awesome? Wasn't that like
It's actually
so much
easy.
fun? It is
Well,
easy.
It's
Let's
not as
see.
hard as it seems.
Yeah,
As cooking.
it looks a
As
lot,
cooking,
it looks a lot more complicated than actually.
Yeah, I messed up on the, actually 2 parts, but the other parts, I wanted to see if y'all would catch it because it's review from stuff we've been doing all year long. So,
I was
Anyway.
so right about the,
yes you were.
and I was like, oh, okay, I guess, alright, okay. And then I was actually right, and I didn't get credit for it. I was
And
just
all the
like-
more reason to be confident in your answer. If you don't think that something's adding up, then you need to question it, especially when it comes to this.
I didn't know why I thought that was right. It just kind of seemed like the right answer in my mind. I don't know, I guess that's Jesus or something.
Well, that's whenever you just argue with me. So, no, you're wrong. I don't know why you're wrong.
And I'm sorry,